Alright, now we're going to start looking at graphs of equations, and we're going to learn a few topics here, sketching graphs. Looking just to identify x and y intercepts, most importantly is symmetry here, and write equations and sketch graphs of circles. Now, what I've done here is I've just broken up some typical graphs, and broke it up into 5 basic blocks. What we have here is y equals x. Well, that's a first degree polynomial. The next one we have here, which is x squared and x cubed, then second in degrees. And now we have h of x down here, which is just the absolute value of x, and k of x represents the square root of x. So these typical graphs are what we really call parent functions. Okay, but we'll get into more of that much later. All right, just to have a basic idea. So, one of my least favorite, and probably everybody's least favorite methods, is actually the table method. And that is this, that we're going to take some values here and do some substitution. So I'll use red. And I'm going to use some easy values here to graph this just to start. And I'm going to leave a little room, but I'm going to start at -1. And then let's go 0 and 1. Now, I'm not sure if these x values that I'm picking are going to be sufficient to give us a good picture of what the graph is going to look like. But as we already know what the parent looks like from what we saw before, we have a pretty good idea of what to expect. So all we have to do is insert those values, and that's just -1 cubed. And, well, that's nice, and then this would just be 0 cubed. Well, that's really nice, and, well, that's just 1 cubed, and that's, again, really nice. So it looks like what we have is this setup. So that means that we have 3 points, and I'm just going to randomly place them, like right here, and I'll try to keep, as symmetrical as possible. But if we were drawing this right now, it looks like it's a straight line. However, we already know it's not. So what we have to do is find some value that's before and some value that's after, and try to make it really big or really small in this case. So the two values that I'm going to pick here are going to just be -10 and 10. So if we just input 10, then that means we're going to get 10 cubed, or 1,000, and likewise up here we'll have a -1,000. So it's a really big number, and we're not going to be on the scale, but if we can see what's going on, if we make this about, let's just call that 10 for right now, and all the way over here about -10, because we don't really have it, and then we'll just break this and say that, right about, we can't go down far enough, really, so, let's actually make 10 about here, just to get the picture, because obviously this is not drawn to scale, but we also don't have, well, it's definitely not drawn to scale. So we'll just say that down here is a point, and we'll label it now as -10, -1,000. And we'll label this other one that's probably, who knows, it's probably up around here or so. And this would be 10, +1,000 here. And then I'm just going to label all the rest of the points that we have. 1, 1, 0, 0, and -1, -1. And now it's kind of clearer to see about the arc that we're facing here. And if we draw it in with a light blue, then it kind of looks looks like it goes like this. Now that's a really rough sketch, and we'll just put down F. So that's just a really rough sketch, but notice we had to put out a lot of lines. However, if we use symmetry in our problem, we would have been able to identify one and only one of these points, but and then get the symmetry here. And it's a little hard to see the way that I've drawn it here, but well, the idea here is if I look at this and I use brown here, you can clearly see that this point up here, which is 10 and 1,000, that there is some number down here that is negative 10 and negative 1,000, and there's a nice, well, it's a little hard to see, but if I could try to draw this in brown, what we're really doing is doing a reflection about y equals x, okay? And what we call this is the third step here. If I go down to symmetry, then what we just talked about was symmetry with respect to the origin, or y equals x. So if we know that there's a point xy on the graph, then we also know that its negative counterparts are also on the graph. Okay? Now, if we think about symmetry here with respect to the x-axis, and I just draw a little, and for the y, I just draw a little coordinate system, then what we're saying in the first one is, well, how is it reflected about the x-axis? So we're basically going like this. Whereas in the respect to the y-axis, we're rotating around here. So if that's the case, and an x and a y does exist as a point, then the x still exists. However, its negative also exists, and you can kind of see that if I drew it like that, those little points. And then, if we look at with respect to y, well, now what will happen is that the x's will change. So, whoops, that's supposed to be this. And what we can see here is that if one x value, if one x value on one side of this, then the symmetry has to exist on the other side. Okay? And what I've done down in this area here is just did a nice little summary. So if we do assume that 1, 2, for example, is on the graph, then if 1 was true, then we would have this point on the graph. If the secondary case was true, in which case we're reflecting about the y-axis, then we would have the point, and I'm going to try to squeeze this in right here, well, it'd be negative 1, 2, and then if we look at the last one down here, then that would be negative 1, negative 2 would also exist. So you'd have to figure out which symmetry to employ. And then once you figured it out, then you can pick which other point might exist on the graph. Alright, let's look at circles real quick. No real secret to circles. Circles are the Pythagorean theorem in disguise. If you can see this, r squared is equal to a squared plus b squared. In which case a is just x minus h and b is just y minus k. The added bonus of using this formula is knowing where the center point hk is, which is nice. So if you're presented with a problem like this, it's very easy to see that if we said, like, let's say 16 is equal to x minus 1 squared plus y plus 2 quantity squared, and did this, then what we could actually see in this case, it's a little easier to see it here, I guess, but if we were doing this out, then what would be the radius here? Well, the radius would be 16, well, whatever units that is, and then the center point would be at -1, 2. So we can kind of go backwards and forwards with these and make it really easy for us to identify circles and whatnot. But in class, we'll do much more in detail with this because there's a very special case in which case r is equal to 1. And this is a very special case. So we'll talk about it in much more detail later. And then if we just move down to x and y intercepts, the only thing that we have to keep in mind is for x-intercepts, the y is 0, and we're going to solve for x. In the y-intercept, we're going to actually set x to 0, so that means let 0 go into x, or substitute 0 for x, and then solve for y.